All right, and we're back. So we're looking at the example Thermos project. We had the title slide, we had the design, and now I want a picture of what you constructed. So this is just very simple, like just paste a picture or pictures of the thermos that you made. Now keep in mind, I just found this, I didn't actually make this thermos, I just found it on Google Images. This person would not receive a good grade. I want you to turn to your partner and try to explain without looking at the screen, because I know it's on the screen right now. Why would this person receive not a very good grade? You're right, because the design right here that you see right here doesn't really match what they made right here, right? I don't see any marshmallows. I don't see any duct tape, right? So that would be a really big problem if your design doesn't match what you actually make, okay? Keep that in mind. Okay, so after you have your design, you included what you actually made, you're gonna test it. So right here, what happened, guys, I put water in the thermos, I put water in a normal paper cup, and I measured the temperature for 10 minutes. You can see my temperature goes down for both of them, right? They both lose thermal energy, and hopefully this happens to you as well. This one lost thermal energy much slower than this one, which is good. I also included a graph. So make sure you include a graph to get a 4 on the rubric. You can see my temperature of the water in the thermos versus the temperature of the water in the normal cup. You can either draw the graph or use Google Sheets to make it. Feel free to reach out for questions if you don't know how to take your data table and turn it into a graph. And lastly, guys, is your reflection. So in your reflection, I describe my constraints and I describe what I could do to improve my thermos. So constraints, I said, to solve the problem of the cold coffee, I had to build a thermos. This was a challenge because of the time, money, and resources which I had to work. I could explain in more detail. I could say, we only had 1 week to do this. If I had more time, I would have, built a thermos, tested it, redesigned it, tested it again, redesigned it, tested it again, made it even better, tested it again, right? We just didn't have the time to do all that. So that's a constraint, right? That's something it's a challenge. It's in between that comes between me and making like the ideal perfect thermos, right? So here you can describe your constraints, okay? For reflection, I'm going to talk about what I could do to make it better. So I said my thermos successfully minimized the amount of thermal energy lost by the hot water. Like it was a pretty good, my tests revealed that it did pretty well. As you can see in the graph though, both my thermos and the paper cup started with the same temperature water. The water in my thermos was 31 degrees hotter after 10 minutes. Ooh, I should say 31 degrees cooler. Let me quick fix that actually. It was 31 degrees cooler after 10 minutes, right? It didn't get hotter. 31 degrees cooler after 10 minutes. To improve my thermos, I need to design a cap for the thermos to minimize the amount of thermal energy being lost due to evaporation and convection. To do this, I'd make sure my log is cut to the size of a peanut butter jar and screw on the lid of a peanut butter jar. I would still need to ensure I included a hole for my thermometer though. So as you can see, I reflected, I said like it worked pretty well. Here's, as you can see on the table, here's how many degrees cooler it became. However, there are ways like I could improve it, and I came up with a concrete thing I could do. Like it's kind of a weird idea, but like I could make it the size of a peanut butter jar, screw on the top, blah, 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 right? So a very concrete way I could redesign it to make it better. Okay, that is your thermos project. So real quick, guys, at the bottom here, you're gonna see how you can get a 4. You get a 4 for a design phase, the construction, the testing, and the reflection. So for a 4 in the design, your blueprint needs to include a list of materials with explanations of how each helps the thermos work, an arrow showing the direction that thermal energy will be moving, and an explanation of how the thermos will work using the vocabulary listed in the instructions. For a 4 for the construction, guys, the constructed thermos uses primarily materials brought from home, super important, and it matches the blueprint, right? It's not like what you made doesn't match what you designed. Keep in mind, guys, that you will also be getting a responsibility grade on Wednesday or Thursday, depending which day you have class, based on whether or not you bring in your materials. Very important. Write it down. Bring in your materials on Wednesday or Thursday for when we're in the makerspace. For the testing, guys, you need to include a data table and graph to get a 4. Both need to be neatly drawn and easy to understand. The data table and graph include the temperature of the water over 10 minutes in the thermos and in the paper cup. And lastly, guys, for the reflection, a 4 is you need to include a detailed explanation of the constraints and a detailed, realistic explanation of how you could redesign your thermos to make it even better. Okay? Whew, that's a lot of stuff. Hopefully you don't have too many questions. If you do, feel free to either ask your teacher who's in the classroom right now or Julio. If they aren't able to answer, make sure to email me and I'll be able to respond from home. Last but not least, guys, if you go to Google Classroom right now, you're going to see everything you need for the week, okay? So right here you see the installation lab. Remember today, you are going to do the installation lab before you get started on the thermos design. Installation lab is going to give you some helpful feedback, helpful background information to do really well in the thermos. Here is where you'll find the thermos project instructions and rubric. You'll also see a link to this video that you're watching right now. if you need to watch it at home. And right here, guys, you're going to see your template. So my suggestion is you don't have to use this. My suggestion is when you make your Google Slides presentation, you just open the template like this, and you go File, File, Make a Copy. I'm going to say, let's pretend my name is Billy. I'm going to say Thermos Project. Actually, I'm going to put it at the beginning. I'm going to say Billy, what's my last name? Billy Roberts, Thermos Project. Make a copy of it, save it, and that's where I can now make all my, I can put all my things in, right? So I can put my picture of my design on this slide. I can put my construction, my test, my reflection, all that. Use the template to do it. I think it's a really helpful way to do it. You don't have to, but it could be really helpful for you. So everything you need is right here, guys. If you have any questions, do not hesitate to email me. This, you only have 3 days to work on it. So today you're designing it. Wednesday or Thursday, you are constructing it in the makerspace, and then on Friday and Monday, you should be testing it, reflecting on it, and finishing up your Google Slides presentation to turn it into me. So this is summative grade. I think I've answered all the questions. I will say, oh, I forgot to mention one of the most exciting parts. Whoever in each class is most successful in their project, like based on their results, based on their design, based on everything, most successful will receive a prize. I'll let you know soon what that prize is, but I promise it'll be worth it. Something good to eat potentially. So whoever makes the best thermos in each class will receive a prize. So go ahead and get to work, guys. And I'm excited to see what all you guys come up with. Have a good day.